The box of negligible size is sliding down along a curved path defined by the parabola y equal to 0.4 x squared. When it is at A, x equal to 2 meter, y equal to 1.6 meter, the speed is v equal to 8 meter per second, and the increase in speed dv over dt is 4 meter per second squared. Determine vx, vy, ax, xy of the box at this instant. Okay, so in this particular problem, we are given the following data, which is a equal to 2 and y equal to 1.6. We are asked to determine the velocity, the component of velocity xy, and the component of the acceleration x and acceleration y. Now, we have that v equal to a at this moment when this is sliding down. Then we know that v equal to a. That's what we know. But we are asked to find vx and vy. Then v is just equal. We know that equal to vx squared plus vy squared, and we add the square root of that. So we know that from this formula that v squared would equal to vx squared plus vy squared. Then we know that h squared equal to vx squared plus vy squared. Okay. But we are also given that the box is following the path when y equal to 0.4 x squared. Then we have y equal to 0.4 x squared. Okay, we are also given this one. Okay, now let me put some highlight here. Okay, now we also need to define vx. What is vx? Yeah, here vx and vy. Vx is simply dx over dt. See, the definition. The velocity is the rate of change of the displacement. So similarly, we have vy equal to dy over dt. The rate of change of the displacements in y components over the time. Okay, now so we then from this formula y equals to 0.4 x squared, we now gonna differentiate this formula with respect to time. So we have dy over dt equal to 0.8 x dx over dt. Okay. Now, what we are looking for is dx over dt. See here, this one. Yeah, that is vx. Okay, so now what we're gonna do is we are gonna replace dx over dt into back to this formula here, back to here, because we are given this formula, so we given back to here to get either vx or vy. See, both works. So now we have a squared. Okay, a squared. I will read them here. we have a squared is 64 equal to dx over dt squared plus dy over dt. Okay, but we know that dy over dt is, we just find here, dy over dt is 0.8x dx over dt. So we have 64 equal to dx over dt squared plus 0.8 x, just replacing, instead of dy over dt, we replace just 0.8 x dy over dt. I'm sorry, dx over dt square. Now we have, so we have an equation of one variable was unknown, dx over dt. So we have now just to solve this problem, this particular equation, to get dx over dt. So now we have that. Solving this one, we have, let's see, 6dx. Okay, so we have dx over dt would be equal to, let's say, 64. We have 64 here. Then we have 1 plus 0.8 x. Just moving this one to here. Okay, let me erase it. I will step by step. So 64, we can make it like this one. dx, we will let's factorize dx over dt square root is a plus 0.8 square, like this. Okay, so we just moving to the other side. Dx over dt would be equal to 64 over 1 plus 6.8x square. Square. So we have dx over dt equal to square root of 64 over 1 plus 0.8x square. Now we just need to plug into the following. We are asked when x equal to 2. Okay, so let's plug in. When x equal to 2, we have dx over dt equal to 64. 64 over 1 plus 0.8 times 2 to the square. Let's square root that. So dx over dt, plug into the calculator, you will see it would be equal to 4.24 meter per second. Now, once we got the dx over dt, which is very easy to get dy over dt, from the previous one, we know that dy over dt is equal to 0.8 x dx over dt, right? So we just to plug in here, dy over dt is 0.8 times x equal to 2, and then dx over dt is 4.24. So dx over dt we have plugged in the calculator, we have 6.78 meter per second. And now this is our answer for the velocity. Okay. Oh, okay, we can also, maybe we can change it to Vx since the problem is as, okay, 4.24 meter per second. Okay, 6.78 meter per second. That's our answer. Both notation are the same, dx over dt. So now we are gonna calculate ax and ay, the component x and y of the acceleration. From the data given by the problem, we know that increase in speed dv dt, which is the acceleration, okay, is right down here, dv over dt is just acceleration. We are asked to calculate ax and ay. We know that a squared equal to ax squared plus ay squared. Okay, which means that a squared equal to dv over dt squared equal to dvx d over dt squared plus dvy over dt squared. Okay, so now we are gonna do this at when x equal to 2 from the problem. When x equal to 2, okay, when x equal to 2, we have the following: y equal to 0.4 x squared. This when the box following this path, the parabola. Okay, we need to go from this, since this the path, the displacement of the box. So we're gonna differentiate this equation to get either dx over dt or dy over dt. Both work. So we're gonna do dy over dt, which is 0.8 as previous we have calculated. Now we still need to differentiate again. The second derivative of the displacement is the acceleration. So we have dy or dt is let's say 1.6 d6 derivative dx. Hey, okay, so dx, this one is d over vx dt. Okay, so we have now calculate that, and also this one dxy or dt is dy. Okay, now we have the following: that we also from the problem we are given that dv over dt is 4. So we have 4 squared equal to dvx over dt square plus 1.6 dvx over dt square. Now, okay, now we're just doing the same thing, just to solve for dv dvx over dt. So we have that, let's say vx over dt, okay, dx square 1 1 plus 1.6 to the square. Okay, so we have dvx over dt square equal to 16 over 1 plus 1.6 square. Right? So we have that dvx over dt is the square root of 16 over 1 plus 1.6 to the square. Okay, that's very easy to compute because we don't need any value of x either y. So from the calculator we can just compute this one. We get, let's say, okay, we have 2.12 meter per second square. Okay, so we have ax is just 2.2 meter per second square. Now it's very easy to compute ay because we know that ay equal to dvy over dt, and then we know that dvy over dt is 1.6 ax, so ay equal to 1.6 times 2.12. So we have ay equal to 3.39 meter per second square. Now we have our answer for this problem. The component of x and y of the acceleration. Oh, let me put it inside the box. Okay, that's our problem here. Thank you.